What is blockchain? Blockchain, simply put, is a distributed ledger of transactions protected with cryptography. So what is a distributed ledger actually? Well, think about money first. Money is really just given its value based upon what everybody agrees it's worth. That's how money works. A dollar is worth a dollar because everybody agrees that $1 can be traded for a certain value, and the way society chooses that value is through a large collective agreement, essentially. So a blockchain and a distributed ledger work that way. If you can imagine a checkbook ledger that has everybody's transactions stored on that, and each page of that ledger is called a block. Each transaction in that ledger is signed using a cryptographic algorithm, and the blocks are connected together using one-way cryptographic algorithms called hashes. They cannot be reversed without an immense amount of computing power. So now you take that copy of the checkbook balance and you hand it to every single person on Earth so that you all know that this computer algorithm proves through math that it's worth a certain value, and everybody can see it. That is how you can form a consensus. And with that consensus and the completely automated system, you get money that does not require an intermediary. And it's not necessarily just money, but you get a store of value that doesn't require a third-party intermediary to prove that a transaction occurred. So, what is a block? A block, as I said before, is a page in a ledger. A block is made up of data, its hash, and the previous hash. So the data is basically something like the transaction. It's just information. It just says, hey, Joe sold, or Joe traded $2 to Bob. That's it. It says something like that. Or it'll say ownership of the piece of land at XYZ location on Earth is in the hands of Bob. Or it does something like contain computer code that can be run like a script. Then you have the cryptographic hash, which is very much like a fingerprint. So you can imagine it's something that is very unique. It's a very large calculation that uses an algorithm. There's multiple cryptographic hashes that computer programs can generate, and those are a hash is a type that is a one-way type of calculation, so you can't reverse it without and get the information in it without having a key. And that is what provides validation of the transaction. And it's calculated with the data that's inside of the block included in the cryptographic hash. So by doing so, they also use the previous block's hash, which it also contains all of the previous block's data, if that makes any sense, because it was already calculated into that previous block. And that hash code, it's just a number, basically, gets mixed in with the next one. And so that creates the locking chain. And what's also amazing about it is that entire chain, even though it's just made up of basically codes, it is all of the transactional data that made up all of those transactions in every block. So right about now, you're probably saying to yourself, what? I do not get this. And I hear you. It's hard to understand. And so bear with me. I'll try to explain it as best as I can. And so this example next will help give us a little bit more information about it and help explain hashes to a better degree. What happens if someone tries to change a transaction, right? We already talked about this ledger thing that everybody can see. So what if somebody just goes in there and changes $1,000 to $10,000, whatever, and tries to pass it off, right? Just puts it in there and says, hey, transaction for $10,000 here, I should be getting $10,000, right? How does this thing prevent that from happening? So if you can recall, the hash code is actually made up of all the data that's stored inside of the block. So all the transactions, so the person that it's from, the person that it's going to, and the amount, right? Because it's a transaction. It's just like address A, amount, address B, and data, right? And the data is just stuff about it. It could be code, it could be some sort of information, like it could be like a music file, who knows. Anyway, all that data gets calculated into the block, and the hash code contains all that data within it. It's the key to that data. So then that hash key becomes the previous hash key that goes into the next block, because it's how they chain them together. The previous hash code is inserted into the block's data. So then that data is part of the new block's data. So if somebody changes one of the hashes, when the computer algorithm tries to verify it, it'll say, calculate to see if this hash is valid. And it'll find out that the hash code is wrong. And that also results in every single block thereafter showing the wrong hash, and therefore will invalidate every block that comes after it. That's simple to observe. It's a simplified pattern, and computers can be shown how to observe that and then come to a consensus as to which block was the correct one, where the the bad transaction was, and go back to that point and fork that code out so that it's no longer part of the agreed upon blockchain. The data is actually still there, which is an interesting thing. So even the data of the bad transactions, the hacked transactions, whatever, is also still on that blockchain, which is an interesting detail people sometimes don't think about. So these networks of computers that all have the ledger, they have to figure out how to agree upon which one is the correct copy of the ledger. Basically, it's just saying which checkbook balance is the right one, or which ones are the right one, is actually what it's like. There's thousands of them, tens of thousands of them, distributed across the globe on different computers on different networks. So this is where the security comes in. There's algorithms called cryptographic proofs that help the computer networks look at the blockchain, go through it, validate the transactions, and then use that to determine the correct answer that shows the truth that everybody is agreeing upon based on the math. And then all the computers compare those and say, yep, this one's right, this one's right, this one's right, this one's wrong. And that's how they agree upon it. Occasionally, a certain segment of the network, in other words, a large number of the computers on the network, might form its own opinion about the blockchain and say, this branch of the blockchain is the right branch, and that is called a hard fork. And in order to resolve that, you have to basically get together with committees of people and look at the proofs and use calculators and computers and have everybody come to a consensus. And what happens most of the time is it forms two currencies. So just touching upon blockchain security, making and this just mostly refers to ensuring the security of the information on the blockchain itself. We've talked about how a change to the blockchain alters the contents of all later blocks, which is easily detectable with a computer, with computer software. So a proof must be completed for every block. And actually, the computers that run the calculations that do the proofs, when they find the answer to the proof, they get rewarded with a currency token. So that's an incentive for a large network of computers to always work on validating the integrity of the blockchain, because they essentially get paid to do it. That's one source of income on a blockchain type cryptocurrency setup. Now, that does not cover aspects of security that go way deeper than this. For example, information security goes down to the server level, to the software level. All of these computers on this network could be, some of them could be infected. Some of them could be infiltrated by a botnet or by hackers, or, they could be unreliable. And so the key is to have a really large network and have really good standards and enforce integrity in your network with boards and different forms of accountability. That way you can add kind of a human element to it that gives it a lot more, strength. So one of the important features of blockchain that people may not understand or know about is the concept of a smart contract. So as you recall, we can store data in the blocks. It's encrypted into the block, so we know that the data is not changed from when it was put in there. And we know that all these computers are running and validating all these blocks. Well, some of the time, they could be executing the transactions as well, right? So there's a transactional element to blockchain in which that's what creates the transactions. And when the transaction occurs, you can create special code that happens that's just a simple conditional, right? It just says, if this, then that, essentially. And that is give the value of this, whatever we agreed upon in the contract, to the recipient. That's it. So it might be money, it might be the value of land, some sort of ownership, it might be a voting record, it might just be a data log for a computer program. There's actually millions of potential applications for smart contracts. It's a massive macro economy, and I would expect it to expand exponentially into the future. So that might have been still a little heavy, right? So let's just kind of cover a quick smart contract based on an insurance model, right? So an insurance contract is just a predefined contract. It just says, here's all the rules, here's what happens when this happens and that happens, and these are the responsible parties, and this is basically the conditions. And it's just a form, if you can imagine, with the data stored in a contract. That's it. Those terms are agreed upon and then encoded into the smart contract. And that gets committed to the blockchain, which can't be changed. as we recall, that encryption makes it unable to be changed. So now you can imagine an event happens to property. Lightning strikes, the house burns down, and that triggers an insurance claim agent to go through their process. And when they go through their process, they trigger the smart contract to fulfill because the policy has been executed and they know that it's time to trigger it. So when the policy gets executed, those terms are automatically executed because they're built into the smart contract. So then it takes the inputs from the policy execution trigger, right? And then it just says, here's what happened, right? They're saying these are the variables that go into the smart contract for it to do its calculation. It runs through all the rules inside of that code, and then what comes out is what the value that needs to be paid out in settlement and to whom. Then the next step is it automatically transfers the value in terms of that currency to the settled person. Very simple, really. This is all done automatically on a network of computers that are agreeing to do this in exchange for a piece of that value. So what are some use cases for this blockchain technology, right? We already covered insurance claims. We can totally automate a big chunk of the insurance claim process. Obviously, we're not going to take out the person who physically goes there and verifies that the house is in the condition that they say it is, right? But it will still automatically handle that. Another idea is self-servicing loans. And then my favorite, being the CEO of Grizzly Peak Software, I'm more interested in the turnkey organization concept, or self-forming organizations that use cryptography and blockchain in order to ensure trust in the organization. Automatic payment systems, offline data integrity systems. That one's kind of, imagine a drone that's flying in Afghanistan and it drops communication with the mothership, for example, and it's still gathering event data. It's taking pictures, it's doing this, it's doing that, and then suddenly it gets back on network because it's in a safe zone. And then it merges its blockchain contract, or not its contracts, but its transactions in with the mothership's copy of the blockchain. And that way the military can know the events, when they occurred, and all of the surrounding data, and trust that it hasn't been manipulated. You could also use it for electronic cash. You can use it for land ownership, title tracking, voting record integrity. So imagine a smartphone voting application with cryptography in it that proves to all people on Earth who could just use it, a publicly shared program that anybody could rewrite to prove that it was correctly written, and do the same thing to validate that the voting record is accurate. And then also a big one is initial coin offerings, which is essentially a blockchain-based IPO, or creation of a company. You exchange value for a piece of a blockchain. After that, the blockchain is publicly traded, and the recipient company receives that funding and then moves forward as a startup, because that's how they get their money. So what are some risks? Right now, 2018, this is what I see. The impact of regulation is a huge risk. The people that are in this now, they don't know what's going to happen. The governments of the world are trying to figure it out, and that could have an unintended impact that they can't forecast for. Reliability, scalability, and performance. So these transactions take a long time. Sometimes some of these cryptocurrencies, are you sure you can trust them really? kind of depends on the network, right? Vendor risks. So you're paying these people to build this blockchain software and they totally blow town with $20 million of yours or something. That's an extreme example, but that's a risk you could face. Security concerns, data leakage, the fact that somebody could infiltrate a network and possibly manipulate a blockchain and use maybe a botnet to take control of a section of a blockchain and then create a fork that moves into the direction that gives them a benefit. And then I think the biggest risk is also lost opportunities. People are a little bit hesitant to change, and blockchain technology is very confusing. It's very technical, and it's hard to wrap your head around. And so a lot of investors and business owners, just normal, middle class business owners, for example, they may not realize some of the stuff that's coming up, and they're losing out on an opportunity that's coming open right now. Even when the market for blockchain related cryptocurrencies is down, what they don't see is what's coming next, and that is the programmatic implementation of these blockchain technologies. So what is preventing the world from achieving mainstream adoption as a technology of blockchain? What are some of the industry challenges right now? I would say that initial costs are really high and the potential for return is too unknown for a lot of people to get into this. Also, the concept of integration with legacy systems. So a lot of companies that are getting into this are saying, well, we already have these other transactional systems that work really well and we use them every day, and this new thing is kind of new, and so it's too expensive to integrate them. Sorry. That's basically, kind of what you're probably going to hear. But there's other sides to this. Then there's energy consumption. The blockchain miners consume a massive amount of energy. They use special CPUs called GPUs that are highly optimized for this kind of calculation, and they burn a lot of energy. And in doing so, that's actually kind of bad for the environment. Some people calculate that the value created is less than, for some of these blockchains, especially the less successful ones, the value created is less than the energy consumed, which makes it worthless, right? The green element is very important. We still have to focus on making technologies that help the planet while also helping in other areas. We don't want to not harm the planet at the same time we're trying to help people, right? Another huge one, and I would say this is probably the biggest one, is public perception. So a lot of people have a hard time understanding the concepts that underlie blockchain, and as a result, it's hard to get people to buy into these things, and if they don't buy into them, they're not going to transact their money using them. So, this video is an example. I'm trying to help people understand it a little better. And then as things start to prove out, I think, when new cool things happen that are related to blockchain that work and are wildly successful, people will start to notice. We had this massive stage where there was essentially kind of like a bubble, and a lot of people made a ton of money, and actually a lot of people lost the money back, but they don't talk about that one so much. But basically, that got people's attention, right? Now people are like into blockchain that had no clue what it was 5 years ago. Privacy and security. The data on blockchains is public, and the transactions could be linked back to you, so they're not necessarily private. And then there's information security issues related to blockchain, not just from hackers trying to attack the networks, but also in terms of the information security of those transactions, like at the point of sale, or identity theft, key loss, key theft, all kinds of different security aspects. It's money after all, right? So these are my personal predictions for this technology. They're just my predictions. I could be wrong, but here goes. In the near term, I would totally expect regulatory impact to be all over the place in the blockchain industry. Regulations are just starting to shake out. Things like regulations on exchanges to make sure that there is integrity in the transactions at the point of exchange. Regulations on taxation. Should it be a currency or is it an asset? And things like that, right? Some countries don't want it. Some organizations do not want it. And those groups are going to form regulations around it, and it's going to impact people that are in progress now. So timing could impact some of your decisions around blockchain based on the near-term regulatory impact, because it's basically coming now. We know the government is aware of it. They're going to do stuff. So I also forecast that in the relatively near future, probably as a result of some of the regulatory impact, we will see some consolidation, right? Bitcoin might disappear. It might not be the thing. Ethereum might, or maybe not. Maybe a Ripple or some other unknown cryptocurrency will come to the top in the next phase. We don't know this. But what I do suspect is some of the big players and the people who really have it dialed in are going to really get it dialed in, and they're going to consolidate their holdings, consolidate their code, lock themselves in. And that will lead to things like platforms that can enable a person to create an automated organization, probably by dragging some boxes around in a UI on a tablet. They'll probably be able to go in there and say, I need an assistant and I need, letters to send out or whatever. This is my product and this is this and this is that. Hit a button and next thing you know, they're selling t-shirts, and they ordered the entire thing up on their computer, right? So that's something I'm really interested in. Automated organizations, little turnkey things that use blockchain as a way to run a company and automate some of the stuff, like keeping track of what happens, essentially, like what events occurred, what were the transactions, and then know that we can trust those. Smart assets, so things that contain high degree of value that's derived from blockchain technology could arise, where we have, I guess this is kind of a future tech that I kind of came up with, but basically these almost like an extension of automated organizations to where it's a higher degree, even to where literally you can, let's say you say, I own a football team, and it runs itself, and you just check up on it on your phone, right? Smart assets, where you just wait for that check to come in, it's running off on the side, and then you're doing what you want to do. That sounds kind of fun to me, actually. And then we have maybe ultimately a fully programmable economy, or multiple economies that are totally programmable. If you really think about it, a blockchain ecosystem is an economy of a kind, and that's why it creates value. So contact me at my website, www.grizzlypeaksoftware.com. This is Shane Larson from Grizzly Peak Software. Thanks for watching my video today.